Alrighty. Looks like it's just you and me again. Wonder if there'll ever be more. Oh well. Okay, we're gonna look at the two questions in the top corner. That top one is definitely band 6. I was looking through this bottom one. I was thinking maybe the fourth part of it. So this part is the band 6 section, maybe. But this first one definitely, there's a lot to it. And I didn't really realize, I had a go at it this morning, didn't really realize how much, like kind of how far it goes. Okay, let's go through the first one. We're only going to do 2 today, but there's like a full page of working out for the first one. Okay, so whenever I look at, I just kind of want to show you what I think when I guess I'm going through these. I guess that's the point of this, and hopefully you think similarly or perhaps better than me. But whenever I'm asked to show something, I kind of just write it first. So required to prove, what have we got? Sine cubed. I guess the first thing you'll notice is the cube's not really nice. Also, that sine 3 theta, sine theta plus, I'm going to take that quarter out because I hate how that's written. And it's also nice because it equals 0. Sine, yeah, okay, good. So the first thing I would have done is broken this up because I hate that. So maybe we'll just deal with that. I'm going to write like a million lines of working here. Let's just screw the first part. So I've got a quarter. Actually, I'm going to write, oh yeah, just write it. So sine, so when you break that up, what do you end up with? You end up with, should I write the thing? It's like sine A plus B. Isn't it sine, whoops. So it's sine A cos B plus cos A sine B. That's how it is, isn't it? Why is that all squiggly? Okay, so using that, sine, and I'm calling that 2 theta and theta. I hate thetas. How much easier is it with an x? Okay, so sine 2 theta. Kind of sucks because now I've got a sine 2 theta as well, but oh well. Cos 2 theta sine theta. At least that's easier to deal with because you can't really deal with a 3 theta. So sine 2 theta is the same as, it's 2 sine cos. And then I've got a second cos, so we'll call that cos squared. Plus, go away, cos squared. So that becomes, now I kind of want everything to be the same. So I guess at the end of the day, I'm going to want to make that a 1 minus sine theta. So maybe I'll deal with this side first. So then 1 minus sine theta, sine squared theta. And then I guess I know that now that I've got this, and it's a minus, which is nice, 3 sine minus 4 sine cubed theta. Okay, so this becomes, is it, how does it work? It's like sine squared minus cos squared, or is it cos squared minus sine squared? I always forget. No, it's cos squared minus sine squared. Okay, and that's the same as 1 minus sine squared, so that's 1 minus 2 sine squared. So I've got 1 minus 2 sine squared sine theta. How many marks is this thing? 2. Man, you've done that fast. So 2, is this what you've written? 2, let's see if we get what you have. 2 sine cubed theta plus sine theta minus, on the right track so far, it seems it, minus 2 sine cubed theta. So then I've got, yeah, 3, this is what you had, 3 sine theta minus 4 sine cubed theta. Nice. Okay, quarter of that, I've got a sine cubed out here, and 3 on 4 sine theta out here. Nice, seems like you're all over it. Plus. So then what? I've got look at this, everything just cancels. Because I take a quarter of 4, and I take a quarter of 3 is 3/4, so that's all gone. Equals 0, which equals right-hand side. Which equal, oh, don't need that. That would be enough. Probably need to show that line of working, but oh, omitted for simplicity. All right. Yeah, this is the fun part, I think. Actually, it's the second fun part. This question is like the gift that keeps on giving. So I guess we'll start with, so we've got x. We're always in danger when we're looking at a cubic. I guess that's why x cubed minus 12x plus 8 equals 0. What am I doing? I'm letting sine 3 theta, no, x equal 4 sine theta. So that means 4 sine theta cubed minus 12, 4 sine theta plus 8 equals 0. Let's expand that. What's 4 cubed? 64. Sine cubed theta. What's 4 times 12? 48. Sine theta plus 8. I guess the clue with these is generally when you've got a 3-part trig question, you're kind of using each of the answers, and considering it's a show that question, that's probably a safe bet. Okay. Where do I go from here? Well, I can divide everything by 8. Is 8 a common factor? Yep. 1. What's 48 divided by 8? I'm having a blank here. That's 6. 6 sine theta. 8 sine cubed theta equals 0. Any suggestions yet? No? Mic check on. Alright. I don't know how, so I have to show that sine 3 theta is, where is it? I lost the question. Is a half. So I guess divide by 2, move up. Yeah. So I guess the clue here is that I had to deal with a sine 3 theta before, and it ended up equaling this, which looks remarkably like this. So I guess that's the clue. And I guess that's why it's a band 6 question, because it takes the keen eye to recognize that. And also if I move this half over, if I swap all the signs, that's going to be a half, and I'm going to have 3 sine theta minus 4 sine cubed theta. And I know that that equals sine 3 theta. And I guess I should say where that's from. That's from I. Yeah. Left-hand side equals sine, yeah. Nice. I'd say that'd be enough for a proof, because I've kind of like used brackets here. I guess you could quote it. I guess you could from there. I guess, I don't know. Nice. Pretty impressed that you've recognized that. It's the last question that I hate, because it calls on year 11 extension 1, and year 11 extension 1 is hard. Okay. So it's saying I need to prove that thing. Now, everything leading up to this is a show that question, and everything leading up to it has kind of gotten to the property of this. So I've ended up with this twice in the last 2 questions. So just thinking about, I guess, the answer, 3 theta would have to be, if this to be a half, it'd have to be pi on 6. If I divide by 3, then I'm going to get pi on 18. And that looks remarkably like, well, it is the solution of this first one. And I guess you can make an argument for the other 2. So I guess the argument would be, so if I had 3, so sine 3 times, so actually, maybe I should write the whole line. No, I don't want to do that. Alright, let's just look at 5. Let's just check these 2 solutions. So 5 pi on 18. So 3 5 pi on 18. That is sine 15 pi on 18, which you can simplify to, if I bring a 3 down, that's 5 pi on 6. Okay, and that's still a half. And you can make the same argument for the other one. I don't really know why I'm doing this, I'm just kind of 25 pi on, where is it, 18? That's the same as sine 25 pi on 6. Okay, how many times does that rotate? That's like sine 24 pi on 6, which is 4 pi plus pi on 6. That's just rotating around the circle twice on 6, which is also a half. So I guess we've got three solutions. The reason I wrote those out was so I could, I guess, write them. So I've got theta is pi on 18. It's also 5 pi on 18. And it's also, what was the other one? 25 pi on 18. Okay, I reckon this is the hardest question we've seen. Because the other ones weren't that bad, were they? This one's very long, and it requires a lot of different skills, I believe. So there's just so many concepts. Like before we were looking at this, and now we've got three solutions to this. So just keeping in mind that it's, I'll just write it, cubed minus 12x plus 8 equals 0. But then we rewrote it as, what line should I use? This one? Do I want to use that one? But you've got 5 pi on 6. 5 pi on... You're talking about this. That's because I had the 3 theta, so that means theta is this part. Is that what you're wondering? I'm not sure. I'll keep going. Lost myself. Okay. All right. Okay, I'm not sure. Anyway, okay, so they told us before that x here was 4 sine theta. So I guess we'll just go over everything we've got. We've got our three solutions to this cubic, but x in this case was 4 sine theta. So that means that x is equal to, now I know what theta is, there's 3 thetas. I've got 4 sine pi on 18, and I've got 4 sine 5 pi on 18, and I've got 4 sine 25, whoops, just 25 pi on 18. Okay, so I've got my 3 solutions. I just need to prove that if I were to square each of these, and this 4 wasn't here, then I'd end up with, what does it say, 3 on 2. So I'm basically got to prove that that's going to be equal to 3 on 2. Now, I can't make an argument as to what this equals at the moment, but I can make an argument as to what the roots of this equation are going to be, or that polynomial, not equation. Well, it's still an equation, I guess. So the things I guess I do know about it, and I can rename these as alpha, beta, and I always screw up gamma. Does that look like a gamma? Okay, now if I were to, I guess my goal is to square each of these. So in order to square each of these, I guess I need to square each of these. And I can't really just like there's nothing I know of it. There's 3, what am I trying to say? There's 3 things I know about that. There's the property where it's like that plus that plus that. What are the ones on the reference? I need the reference sheet. Reference sheet. Where are they? Obviously, there they are. Okay, I know. So when they're added, we've got minus b on a. When there's each of the products, I've got c on a, and then their whole product is minus d on a. So what I want to be able to deal with is something that involves a square. It's kind of hard to recognize this. I feel like it's a pretty mean question because there's not much scaffolding, but where I want to kind of end up is with a version of these that are squared. And the only way I can really do that is if I were to just write like the sum of them. and then I squared the whole thing. If I expand that, I'm going to end up with each of these and each of these squared, which is what I want. So I guess that's the only real way you could kind of get to that. So if I just write the expanded version of this, okay, I'm going to need a massive line of working here. This is pretty, how many marks is this? This is 3. Yeah, it's 3 marks. You earn marks here. This is actually last year's HSC. It's one of the last questions, 14. So I guess this would be the one where you spend a lot of time towards the end. So what have I got? I got a squared. See, when I've got a cubic, I need to write them next to each other so I can actually FOIL them. I don't know about you, but I can't see it properly. So alpha, and then alpha beta, and then alpha gamma, then beta squared, then alpha beta, then beta gamma, then gamma squared, then gamma beta, and gamma alpha. Well, so what I've got is alpha squared plus beta squared plus gamma squared, which is what I want. That's what I want. So I'll just chuck them in brackets, and then I've got 2 of everything else. So I've got the alpha beta, I've got the alpha gamma, and the beta gamma. How can you tell that they are the roots? Because where have I got? Are you asking how I tell that these 3 are the roots? Is that what you're asking? Oh, you get it now. Okay. Now I want this. The whole point of this was to write each of these squared. I've got each of these squared here. So let's get this by itself. I'm going to move him over there. But at the same, let's just substitute as well. So alpha squared plus beta squared plus gamma squared. I know what that is. And then I've got 2 times, now each of these added together is C on A. So C on A is, that's A, B would be the x squared, C, so it's minus 12 on 1. So that's just minus 12. This thing on the here is each of these squared. So minus B is just 0. So this left-hand side is just going to be 0. So let's move this 24 over. Oh, minus 24. Minus 24 equals each of these. So let's actually write what they are. Sorry, I've stuffed that up. That's this. 4 squared sine squared pi on 18. 4. Oh, hang on, I'm going to add them. 4 squared sine squared 5 pi on 18 plus 4 squared sine squared 25 pi on 18. Okay, I can factor out 4 squared and divide by it. That gives me my minus 3 on 2. Did I need a minus or did I need a plus? Oh no, I needed a plus. Oh, I've stuffed it up when I moved it. Sweet, that's actually exactly what I need. Surely this is the hardest question we'll have to do. They reckon the Extension 1 test from last year was the hardest HSC question. Hardest HSC test last year. And I can kind of see why, just judging by this question. I don't think I would ever have gotten this by myself if I just kind of went through it in test conditions. I definitely wouldn't have, yeah. Yeah, there's a lot. I would have had to sit there for like half an hour without the pressure of the test. But yeah, I tried to do it and I didn't get this far. So pretty mean question, but at least you're exposed to, I guess, the level of questions. At least having exposure to this, you can kind of see that, you know, true questions can become polynomial cubic questions. Okay. Let's do question 8. This looks a little bit nicer. Trout and carp are types of fish. Cool, thanks. A lake contains a number of trout. At a certain time, 10 carp are introduced to the lake, so it hasn't told us what time that is. Do you know if Ty got it? No, I should ask him. I wonder if you... Oh, I can look that up. I can look that up. How do I do that? Oh no, I have the sheet on my desk at school. I can see, so when you do the HSC, I get given like exactly what questions each person gets right and wrong. It doesn't tell me what they wrote, but I can see how many marks I got in each question. You have to remind me when we're back at school, because I do have that. Yeah, okay, what are we doing? As a consequence, the number of trout decreases according to that. How many trout were in the lake when the carp was introduced? Okay, well, the carp was introduced at time, are we calling that time 0? How many trout were in the lake? At a certain time. Okay, let's just call that time 0. So at t equals 0, the number of carp, so n, was at 375 minus e to the power of, well, that's just going to be 0. So the number of trout is going to be 374. Got to be careful with that. That's I. Yeah, that last question was mean, hey? When will the population of trout be 0? Okay, so when will n equal 0? So 0 equals 375 minus e to the 0.04 t. That's right, yep. Now let's move that over. So e to the 0.04 t equals 375. 0.04 t equals ln 375. T equals ln 375 on 0.04. It's approximately 148. So 100, what time is it in? Months. 148 months. When t is the time in months after the carp was introduced. Yeah, you reckon that should say afterwards? I reckon that should say after, hey. Oh wait, at a certain time after. Am I reading that? Oh, this, after. Yeah, right, so t is 0 when they are introduced. Yeah, thanks. Didn't read that properly. You've got to read the whole question. Okay. I. Sketch the number of trout as a function of time. Okay, well, I've got 2 points. This is 0.374, and this is 1.480. So I've got 2 intercepts. So that's the t-axis, that's the n-axis. When t equals 0, n is this, so that's 374. N is 0, t is that, so that's 148. The fact that it's an exponential probably tells me it's going to curve, so let's just do that, and that will suffice. It says below the equation. Yeah. Alright. How much room do I need for this next one? A lot. When is the rate of increase of carp equal to the rate of decrease of trout? Okay, so the rate of increase, that's just dp dt. So dp dt, when is that equal to the rate of decrease of the trout? So the trout is this, so dn dt. Now because one of them is increasing and one of them is decreasing, I'm going to have to take the absolute value of the one that's decreasing, or just put a minus in front of it. So the decreasing one is the trout, which was the top one. So let's just take the absolute value of that. I know what what do I know? I know actually, dn dt, let's just find the derivative of that. That should be easy. There's 375 goes, there's just a minus e minus 0.04 e to the 0.04 t. Agree with that? Yeah, nice. dp dt, we're told is 0.02p. Well, that sucks because that's a differential equation. That's actually the like your standard exponential growth and decay equation. So you could probably just jump. The minus is so much simpler. Yeah, okay. Fine, I'll put a minus in front of it. Minus. So that means minus plus. There we go. Alright. Differential equation. I don't know, to be honest, I don't know if you could just jump straight to like AEKT or whatever. So I'm not going to do that. I'll just go the long way, which means I've got to separate everything. So that's going to be 1 on P dP and 0.02 dt. I'll take the integral of both sides. That's going to be ln P equals 0.02 t. I'll put a plus c in. Not going to get me there. Okay, what do I know? I know that at a certain time, the carp is 10. So at a certain time, I'm going to call that was 0, wasn't it? So when t equals 0, p equals 10. So that means ln 10 equals c. Oh, okay. So then ln p 0.02 t plus ln 10. So that means ln, let's just move that, 0.02 t. That means p on 10 is e to the 0.02 t. Right, so far, p equals 10 e to the 0.02 t. Why did I do that? Because I was trying to find dp dt, and I know what p. Oh, okay. So let's just go to this. So then dp dt equals 0.02 10 e 0.02 t, which is 0.2 e 0.02 t. Oh my god. Okay. Now we have each of these. We have this, and we have that there. So I can equate them. So let's go like that. Let's do that. So dp dt was this 0.2 e to the 0.02 t equals 0.04 e to the 0.04 t. All right. Okay. Holy moly, this is a long question. This is just 4. We'll do 5 still. All right. Let's move. What way do I want to move that? What's 0.2? 0.04. 5. Oh, cool. Let's move him that way. That puts a 5 there. Let's move him that way. So that's e to the 0.04 t on e to the 0.02 t. Okay, that's the same as e to the 0.02 t. I just minused. Is that right? What is the question asking? When is the rate? I'm looking for t. Okay, oh, I'm almost there. So ln 5 equals 0.02 t. T equals ln 5 on 0.02. Ln 5 0.02 80. T is approximately 80. Whoa, 80 months. Okay. When is the number of carp equal to the number of trout? Okay. So that's asking when is the number of carp, which is p, equal to the number of trout, n. So I have each of those equations. Yes, p is down here. So that's 10 e to the 0.02 t. N is, do I have n? Surely. Sure. Oh, it's in the question. 3, 7, that's a 5. 375 minus e to the 0.04 t. Okay. Now I've got to find t. So you have to give an approximation. Oh, yeah, you're right. I didn't say what's the rate of increase. I just said the rate of increase. I just wrote 80 months. I know what the answer has. It was 80.7. I could just write that. 0.47 months, maybe. Maybe I should do that. I probably should do that. Probably I should add that line. Don't want to get a rounding error. All right. There's a bit of a trick with this part of the question, and I guess my first thought would have been, well, I can't get t by itself because of this. Like I can't really get the e's on one side and factorize or anything like that. But in a question like this, you just got to, and particularly with an exponential, you just got to look out for powers of an exponential that might be double of each other, and you can turn them into a polynomial. So let me move the highest one, so this one, so it's positive. So I'm going to have e to the 0.04t plus 10 e to the 0.02t minus 375 equals 0. And if I just factor out like a squared in this, so I'm so e to the 0.02t squared plus 10 e to the 0.02t minus 375 equals 0. I mean, if you've gotten most of these answers, then you'd be pretty good. But like, yeah, you'd kind of look at this and be like, well, these two are pretty similar. Their only difference is a square, and it kind of looks like a polynomial anyway. So then if I let e to the 0.02t equal x, so then I've got x squared, oops, plus 10x minus 375 equals 0, and then I can factorize that. I've already done this, so I know, but like, I find it pretty difficult to factorize this, so I'd probably use the quadratic formula. But from before, it was x minus 15, x plus 25. Okay, so that means x is 15 or minus 25. Now, just simply by looking at this, I can't have a negative x value, because a negative can't come out of this, so it can't be this. Get rid of that. So then x equals 15. It's got to be positive, I guess, make a justification. Now, that means that e to the 0.02t is 15. So I've just put old mate from up here back. And then you can keep going. 0.02t equals ln 15. T equals, there's a lot of lns over decimals. Which equals, so ln 5, 0.02. Did I really just get 80 again? Oh, 15, not 5. There we go, 135. 135.4. So that many months. Okay, look at that. That was two pretty insane questions. I don't know where that other one's from. Oh, HSC. Yeah, look at that. Question 16. That star means it was either advanced. I think that means advanced. I think a dash means extension 2. So like question 16's towards the end. 14 is 100% towards the end. I'm pretty sure that's the last question. Oops. So yeah. Alright, I'll upload those and I'll go through. Oh, I've already had a go at, I've started to have a go at this one on the left here. And it was pretty fun actually. So I might go through that and I guess see how much time we got. We'll go through both of these. Yeah, this one's like 4 marks, this is 5 marks. So that might be a longer one. But yeah, I guess I'll see you Thursday.